So do I get to choose?
Yes.
Okay, so let's choose 26. On page 631. Here's the system. X minus 3z equals negative 2. 2x plus 2y plus z equals 4. And 3x plus y minus 2z equals 5. It happens that this system doesn't need any pampering, right? It's all in the correct order. X below x, y below y, z below z, equal symbol, free term. That's okay. It's possible. The coefficient is 0. Can anyone give us the augmented matrix by rows?
1, 0.
The more zeros, the better.
Right. Negative 2, 2, 2, 3, 1, negative 2.
Good. What is the first step?
Get the first one.
To get the 1 up there. Lucky, it's there. Good. Then I will use it to get the corresponding zeros. I need a 0 here, and I need a 0 here, and I have to use row 1. Notice that we used row 1, then we used row 2, and then we used row 3. There is no question about it. Row 2 and row 3. What do I need to multiply row 1 by to eliminate 2? Correct. What do I need to multiply row 1 by to eliminate 3? Everyone can follow this, right? Stephen is not the only one, right, who can keep up. Is that correct? Okay. Which row do I copy at this stage? Yes, it's the one that I'm using currently. 1, 0, negative 3, negative 2. So now, 1 times negative 2 plus 2. 0 times negative 2 plus 2. Negative 3 times negative 2 plus 1. Negative 2 times negative 2 plus 4. That's it. One times negative 3 plus 3. 0 times negative 3 plus 1. Negative 3 times negative 3 minus 2. Negative 2 times negative 3 plus 5. Perfect. What did I accomplish? A lot. Where is my focus next? Second column in the middle, because I want what in there? What is the easiest possible step right now for this problem? Exactly. Let's swap. So row 2 becomes row 3 and vice versa. I copy 1, 0, negative 3, negative 2. I copy 0, 1, 7, 11, and 0, 2, 7, 8. Which row do I have to use now for sure? Yes, multiply by something and add it to the first. And row 2, multiply by something and add it to the last. However, there is no need to multiply and add to row 1 because I already have the 0 in this particular case. But I need to multiply something, the second row by something to eliminate this. Negative 2. Good. Which row I have to copy for sure? It happens that I have to copy the top as well, but which row I have to copy because I'm using it? Yes. 1, 0, negative 3, negative 2, 0, 1, 7, 11. And of course the 0 here. 1 times negative 2 plus 2. 7 times negative 2 plus 7.
negative 7,
Perfect. 11 times negative 2
negative 22,
plus 8.
negative 13. Negative 14.
Very good. What did I accomplish? A lot. Where's my focus now?
Very bottom.
Exactly. What should I do to get a 1 in here? Without a 1 in here, I cannot eliminate the top.
By 7.
Yes, I will divide row 3 by negative 7. Good. So I have 1, 0, negative 3, negative 2, 0, 1, 7, 11, 0, 0,
1.
and
7.
2. Good. Which row, finally, which row I have to use to add it to the first and to add it to the second? Good. So I multiply for the first one, I multiply by 3, and for the second one, I multiply by,
Negative 7.
that's it. And this will be the last step. Final step. So I copy 1, 0, 0, 1, 0, 0, and 1, and 2. Ready? 1 times 3 minus 3.
0.
1 times 3 minus 2.
1.
1 times negative 7 plus 7.
0.
2 times negative 7 plus 11.
Negative 14.
It appears, I'm not certain yet, it appears that the solution is
1. Negative 3.
very good. I have to go back to the original problem and check my work. 1, negative 3, 2. Ready? 1,
Minus 6.
it's not working. 1, 3 times 2.
Negative 6.
Yeah. Okay, I messed up somewhere. So let's check 2, 1, make sure that I didn't, one little sign messes up the whole thing. Okay, so we had negative 2, correct. 1 times negative 2, yes. That's 2. 6, that's 7. That's 4 plus 4 is 8. With negative 3, I get 0. I get 1. 9 minus 2 is 7. 6 plus 5 is 11. I don't see any mistake here in the first step. Do you see any mistake here in the first step? So times negative 2. Negative 6. That's 6. Say it again. We didn't switch anything.
He's talking about he's talking about where we flop the second and third row.
Oh, no. Because again, if I have a grocery shopping or shopping list, right, it doesn't matter. The order is not important. So I don't see any mistake in the first row. Let's take a look at the second step. We swapped. Let me see, make sure that I copied everything correctly. 1, 7, 11, 2, 7, 8. Correct. Okay, then we multiplied the second row by negative 1, by negative 2. Negative 7. Negative 22 minus 14. Correct. Then this was 2, 7, negative 3. Okay, with 3, we got 0. With 0 times 2 is 6. Oh! So 3, that's 0. That's 6 minus 2 is 4. Okay. So let's check the last step one more time. So 1 times 3 minus 3 is 0. 2 times 3 is 6 minus 2 is 4. So 1 times negative 7 is negative 7 plus 7 is 0. And this is negative 14. Okay. Ready? Good. So it's 4, negative 3, 2. Okay. So negative 3 times 2 is negative 6, plus 4 is negative 2. This is 8, minus 6 is 2, 2 plus 2 is 4. 12 minus 3, 11. 12 minus 3 is 9. Thank you. Thank you. One more time. 12 minus 3 is 9. Correct. Minus 4 is 5. Correct. Don't give me another heart attack. Thank you. So now, only now I can say yes. Any questions? Should we work on another? Should we work on another problem? It's a system of three linear equations in 3 variables. It's a method, yes. It's a method that we have to learn. So one more time, do we need another example, or we move on? You can argue with me, but it's not me. Okay. Do we need another example? Is that a yes or a no?
Yeah.
Very good. So let's take a look at another. Let's say 27. 27 on page 631. X plus y plus z equals 4. X minus y minus z equals 0. And x minus y plus z equals 2. Let's see if this is as nice as it looks with all these nice coefficients. Can anyone give us the augmented matrix?
1.
That's the first equation. The second one is perfect. And 1, negative 1, 1, and 2. Very good. Again, I have accomplished the first spot. So then I have row 1 gets multiplied, and row 1 gets multiplied. Yes, and also by negative 1. Very good. Which row do I copy at this stage? Yes, because I'm using it. It would not change if I'm using it. Okay, 1 times negative 1 plus 1. 1 times negative 1 minus 1. 1 times negative 1 minus 1. 4 times negative 1 plus 0. Awesome. Well done. 1 times negative 1 plus 1. 1 times negative 1 minus 1. Perfect. 1 times negative 1 plus 1. Nice. 4 times negative 1 plus 2. Perfect. So the first column is done. Where am I looking at right now?
Second column in the middle.
Yes, second column in the middle. Can I make it 1 in here? Easily. I don't have to swap. Can you swap? Yes. But it's easy now to create a 1 in here. By doing what? Very good. Perfect. So then I get 1, 1, 1, 4, 0, 1, 1, 2, and 0, negative 2, 0, negative 2. Perfect. Now I'm after a 0 here and a 0 here because I have the corresponding 1. I will be using row 2. Multiply by something and add it to row 1. And row 2 multiply by something and add it to row 3. What do I multiply row 2 by to eliminate this? Very good. What do I multiply row 2 by to eliminate this? Very good. Awesome. Well done. Great. Which row do I copy for sure? Yes. 0, 1, 1, 2. Well done. Okay. 1 times -1 plus 1. 1 times -1 plus 1. 2 times -1 plus 4. Awesome. 1 times 2 minus 2. 1 times 2 plus 0. 2 times 2 minus 2. What did we accomplish? A lot. Now what do I want? Where is my target next?
Third column.
Exactly. So I want to divide the row 3 by? Exactly. And here's what I get. Since this is a 0 already, I only want to take care of this. So I will have to multiply row 3 by and add it to row 2. By what? Negative. And this will be the final step. One times -1 plus 1. 1 times -1 plus 2. The solution appears to be, do I know for sure? No. Anything can happen. So here's our system. We're going to check, what was it? 2, 1, 1. Let's try. 2 plus 1 plus 1. 2 minus 1 minus 1. 2 minus 1 plus 1. Only now I can say, yes, indeed, that is the solution of a 3 by 3 system of linear equations. Any questions? Any questions? Say it again. Yes, of course. Okay, I still have about roughly 9 minutes. So I would like to just give you the idea for the last section and no more new, yes?
No, go ahead.
No more new material after this. This is it. Okay. 8.1. Last topic. Sequences and the summation notation. Also called sigma. Sigma notation. Okay. So this is the Latin S, correct? Well, this symbol is still an S, but it's a Greek letter. And this is called sigma. But it's still an S. Okay, but this is more convenient for what we're trying to do now. That's why we're not using this. We're using this notation. Okay, so let me ask you this. If I have, let's say, 1 squared plus 2 squared plus 3 squared plus ... let's say plus n squared. Is there another way of writing this? Yes, it is. And here it is.
That's the end, right?
N, yes, lowercase n. So 1 squared plus 2 squared plus 3 squared plus ... n squared. I equals 1, where 1 is the lower limit from I squared, from I equals 1 through n. What does this mean? When I is 1, I have 1 squared. Plus, when I is 2, I have 2 squared. Plus, when I is 3, I have 3 squared. Plus, dot, dot, dot. When I is n, I have n squared. In other words, this. It's just a different way of writing it. I'm sorry? Lower limit, limit, and this is the upper limit. Here's a simple example. The sum from I equals 1 through 5 from 2i plus 3. How many terms will this summation have? When I is 1 will be 1 term. When I is 2 will be a second term. How many? 5. Very good. So I would like you to give me the first term, no calculations required. I would like you to give me the second term, and then the last term. Can anyone dictate the first term? 2 times 1 plus 3. Perfect. 5. I just want everyone to see it. What will be the second term? 2 times 2 plus 3. What will be the last term? 2 times 5 plus 3. Now, if you want, you can add them up. You're correct. The first one is 5. The second one will be 7. The third one will be, so 2 times 3, 6 plus 3, 9. Plus, the next one will be, and plus 13. You can add them if you want. So this is 20, this is 20, and this is 5. So 20 plus 20 plus 5. Okay, I would like to practice the summation notation one more time.
Can you keep that up for this?
Sure, yes, yes. Okay, let's look on page 752. Let's look at 34. It caught my eye. 34 on page 752. We are given the sum. It doesn't have to be I, it can be k. This problem has k, from k equals 1 through 4, from k minus 3 times k plus 2. The index in this case, or the generic term, is determined with k, not I, doesn't matter. Good. So they want us to calculate this. First of all, how many terms will you give? 4 terms indeed. So please give me the first one. Do not multiply, I just want everyone to see what it is first.
Okay.
1 minus 3 times 1 plus 2, plus the second term. 2 minus 3 times, very good. So it's clear. Plus the third term, 3 minus 3 times 3 plus 2. And the last one will be 4 minus 3 times 4 plus 2. I wanted to, yes, you can multiply at first, but yes, please. It's a sum. Very good question. If it's S, yes, it must be the sum. Yes. We will not look at the product. The other possibility is the product with pi. We're not going to look at that. We're only looking at summation notation. So now if we're asked to determine, I think we're asked to determine this. This will be negative 2 times 3. This will be plus negative 1 times 4. This is going to be 0 because 3 minus 3. And then, plus, this will be 1 times 6. So negative 6 minus 4 plus 6, the answer is negative 4. Any questions?
Can we do one more?
Yes. Okay. So let's look at 31. On page 752. And we have the sum from I equals 1 through 4 to I squared. Since 2 is a constant, 2 can go outside of the summation notation. So this can be replaced by this. If it is a sum, like we had here, we couldn't, unless we separated the summation. But here we couldn't do that. Here, this is a constant. You can go outside. So how many terms will you write?
4.
Very good. Please give me the first term. Plus, plus, plus. That's it. Yes.
You said, okay, I see what you did. You put the 2 and outside.
Yes, because it's a constant. Otherwise, I would not. So this is 2 and 1 plus 4 plus 9 plus 16. Always do this. 10 plus 20. So it's 2 times 30, which is 60. Yes, yes. I just want one. I know I have 1 minute left, so I just want to present the factorial notation. For example, 4 factorial. 4 factorial is 4 times 3 times 2 times 1. By convention, yes?
I got a question about
Please.
what you just did.
Yes.
So, express the sum using notation, the way you have it, is kind of different. I kind of wanted to see it.
Which one are we?
X over 27.
Okay, the first one or the second one?
I don't know which one is first or second. It's the same. The one with the lot of writing on the front. And both.
So the 1 plus 3 plus 5?
Yes.
Okay, so the sum is from I equals 1 through n from 2i minus 1.
Oh, then we just write it out. Okay.
So from I equals 1 through n from 2i minus 1.
Okay. It was backwards. I got it.
We were given the terms and we were asked to use the condensed form.